Welcome to this predicted paper from onmaths that is based on the advanced information given to us by the exam boards. Please use this paper in addition to your other revision. You can complete a unique version of this paper by going to our onmaths site. Onmaths is full of free content to help you prepare for your exams, such as topic-based papers, demon questions and mini mocks. If you like what we do, please consider subscribing. To answer this question, we basically need to find the lowest common multiple of the 10 minutes here and the 15 minutes here. So we're going to start off just by doing the 10 and 15 times table. So it'd be 10, 20, 30, and 15 times table with 15 and 30. So the lowest common multiple is 30. So after half an hour, these buses will sync up. They'll both leave at the same time. And all buses start service at 9 o'clock. So it will be half an hour after 9 o'clock, which will be 9:30. So we need to rewrite this fact here so that it looks like this. So I'm just going to focus on this fact, and what I'm going to do is divide 99 both sides. So we end up with 24 equals 2,376 divided by 99. Now you can see that that looks like that, which is kind of the point. So I'm just going to swap that around. So 2,376 divided by 99 equals 24. And I'm going to write this underneath so we can see the similarity. So 2,376,000 divided by 99,000 equals. Okay, let's have a look at what's happening between these two numbers. So this part here is multiplied by 1,000, and this part here is multiplied by 100. So what effect is the fact that the first numbers multiplied by 1,000 going to have on our answer? Well, it's obviously going to make it 1,000 times bigger. So it will make it 24,000, won't it? 2, 3. So that's that bit done. But what effect will multiplying the denominator have by 100 on our answer? Okay, so if you think about a half, if we times the bottom by 100, it becomes 1 over 200. Now, what is this compared to that? What is 1 over 200 compared to 1/2? Well, it's 100 times smaller. So when you're doing stuff to the denominator, you're actually making it smaller. So this times 100 is making our answer 100 times smaller. So we just knock off 2 of the zeros. We divide it by 100. So our answer will be 240. So we're asked to reflect this shape along the line y equals x. And y equals x is a diagonal line where all the x values are equal to the y values. So at the bottom here we've got x is 10 and y is 10, so that coordinate would be 10, 10. And then obviously this coordinate 4, 4, etc. So we need to reflect it across this line. And so if I pick a point, I'm going to pick the top one. We can see it goes 4 diagonals to hit that line. So 1, 2, 3, 4, so it will go another 4 diagonals. So that will be one of the coordinates there. And I'm going to do the same with the bottom one. So 1, 2, 3, 4, 5, 6 diagonals. 1, 2, 3, 4, 5, 6 diagonals. So it will be there. And then finally, I'm going to do this slightly harder one. So we've got 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Kind of goes over the other one. Ends up here. So if we join these up, and we need to label it B. We've got to first of all work out how many parts there are altogether in our ratio. So we've got 51 saying yes, 7 saying no, and 13 undecided. So altogether, we've got 51 plus 7 plus 13, which is 71 parts. Now each part is equal. So to find out the value of one part, we're going to do how many students there are, which is 2,911, and divide it by the 71 to find out what one part is worth, how many students are in one part. One part's worth 41 students. So each one of those parts in the ratio is 41 students. Now yes, because it goes yes, no, undecided, yes will be the 51 there. So it's 51 lots of 41 students. 51 parts with each part representing 41 students. And when you multiply those together, you get 2,091. So our answer is that 2,091 students responded with yes. The experimental probability is the successful outcomes divided by the total number of outcomes. So we're looking for the probability that it's white, so it's going to be 25 over, and we're just going to do 35 plus 25 plus 31, which is 91, and that's our probability, 25 over 91. Be careful when it says total, you must include all of the outcomes, so red, white and other. So what we do is we notice that to get this 10, we add the 3 and the 7. To get this 17, we add the 7 and the 10. And to get this 27, we add the 10 and the 17. Whenever we have this kind of sequence, it's called a Fibonacci sequence. You essentially add the previous two terms to get to the next term. And so what we need to do is just simply add the 17 and the 27. When you do that, you get 44. So our next term is 44. There are a number of different ways of working out this question. You can find out the amount of tissues per penny. You can work out the amount of, or the price of one tissue, or you can get all the amount of tissues into the same amount. I'm going to find out the price per one tissue. And we're going to start off with the 24. And what I'm going to do is I'm going to convert the money into pence just to mean that we don't have as much decimal. And we're going to do 807. I'm going to divide by the 24 to find out the price of one tissue. So that is 33.625. And so I'm just going to round that to 33.63. I'm just going to round everything to 2 decimal places, which says in the question. Next one, we're going to do the 20 soft tissues. So this time I'm going to do 683 divided by 20. When I put that into the calculator, you get 34.15, so that's already 2 decimal places. And then finally we're going to do the 15 soft tissues. So we're going to do the 623 divided by 15 to find the price per tissue. It should be 41.533 blah blah blah, and rounded would be 41.53. So if you buy 15 tissues, it will cost 41 pence. 20 tissues, it will be 34 pence per tissue, but 24 tissues will be 33.63. So that's by far the cheapest. The best value is the 24 tissues box. Now, there's such thing as buying in bulk. Generally, the more you buy of something, the cheaper it is. Don't rely on that. Both in the GCSE, both in the exam, and in real life. Sometimes in real life, if you buy more of an item, actually per tissue, sometimes it becomes more expensive, especially if there's a special offer on the smaller box. Here we're given a triangle, and we're not actually given the values of each of the angles. We're given them in terms of x, but we know that they're going to add up to 180. So we're going to do the 20x plus the 2x plus the 23x, and we know that it's going to equal 180. And the reason is that its angles in a triangle add up to 180. Okay, let's get our tram lines in. Because we've got algebra and we're solving here, We're going to put our tram lines in. Now on the left hand side we need to add these x terms together. So 2x plus 23x will be 25x, plus the 20 will be 45x. And what we're going to do to get x on its own, we're going to divide both sides by 45. So we're going to divide by 45 both sides. And we're going to end up with x equals 4. So firstly, we're going to work out what the percentage increases are as a multiplier. So we start off with 100%. Jane has a 1.2% interest pay rise, sorry, and so that would be 101.2%, and we divide that by 100 to make it a multiplier. So the multiplier is 1.012, so we get the 20,000 times it by 1.012, and that gives us 240. Next we do the same for Lenny, so that is Jane. And so let's do Lenny. And so that's 100% plus the 1.5% will be 101.5%. Make that a multiplier, 101.5%. We divide that by 100. Which give us 1.015, and then finally what we do is we get the 17,000 times it by the multiplier, and when we do that we get 255. So Lenny has 255, Jane has 240. So it says which of the employees has a larger pay increase and by how much. So the answer will be Lenny, and it's by £15 because that's the difference between these. There's a very specific way to draw a perpendicular from a line. What you do is you get a pair of compasses and measure roughly 3/4 of the way between A and B, and draw an arc from point A, and we're going to draw an arc from point B. And you can see that the two arcs intersect here and here. So what we're going to do is just draw a straight line that join up where they intersect. Leave your workings out, your arcs, on the page when you do this to make sure you get full marks. We can't work out what x is straight away, but we can find this value here. And we know with Pythagoras we can find a third length if we've got other two in a right angled triangle. So a squared plus b squared equals c squared. And a and b were labelled. C is always opposite the right angle. So it'd be 49 squared plus b squared equals 68 squared. And 49 squared is 2,401. And 68 squared is 4,624. So we are solving here, so let's get our lines down. And we're going to start by subtracting the 2,401 from both sides. So we've got b squared equals 2,223. Then we're going to square root both sides, and we've got b equal to 47.148, blah blah blah. Okay, we're now looking at the second diagram, and this time we're going to have A, we've got our B, and we're going to call X the C. So it'd be A squared plus B squared equals C squared, but this time A is 39. B we are given as 47.148, we've just worked that out. And we're looking for C. In fact, we can call it X now. Okay, so we need to square that. So we do 39 squared plus 47.148 squared, and that will be 3,744 equal to X. squared, and we'll just get our lines in because we need to square root both sides, and we get 61.188 blah 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 is equal to x. It says it wants its two decimal places, so that will be 61.19. So let's look through this question to see what information we're given and what information we're looking for. So we're given the acceleration is 13 meters per second squared. We're also given the distance is 19, and we're also given the end velocity, which is v, is 34. And we're looking for the initial velocity. So which of these formulae include A, S, V, and U? That's got a T in it, that's got a T in it, so it's going to be this one here. So let's write that out. V squared equals U squared plus 2AS. So that would be 34 squared equals U squared, because that's what the one we're looking for, plus 2 times 13 times 19. Okay, so let's just work these parts out. And so we've got 2 times 13 times 19, which is what, 494. And it turns into a solving part, so we're just going to solve this. So the first thing I'm going to do is subtract 494 from both sides. And so we're left with 662 equals U squared. Then we're just going to square root both sides. And so square root of that is going to be 25.729 blah blah blah. And it says it wants its two decimal places, so it's going to be 25.73. When we estimate, we normally round to one significant figure. So what I'm going to do is just rewrite this question, but rounding everything to one significant figure. But I'm just going to miss out this square root for now. So 3.3 would just be 3, and 4.7 would just be 5. Now, the problem with this 27 is square rooting 27 is difficult, especially without a calculator, and estimating should be done without a calculator. But if I round it to the nearest significant figure, if I round it to one significant figure, that will make it 30. Now 30 is no easier to work out. So square numbers are a bit of an exception. When you've got square root, it's a bit of an exception. You've got to find it to the nearest square number. So 27 to the nearest square number is 25. So square root of 25 is 5. And then 5 take away 3 is 2, times 5 is going to be 10. So our answer is 10. There's a very specific way to draw an angle bisector, and you start off with a pair of compasses and put the point on B, and then draw an arc from B. And it doesn't matter what the distance is, as long as it's kind of roughly maybe halfway between A and B. It doesn't matter what the distance is. And then at the 2 points, so here and here, that our arc intersects line AB and BC, we're going to draw another arc up here. So I'm just going to show you because it's normally easier. So an arc over here, and I'm going to do an arc from the other one over here. Then what I'm going to do is I'm going to join where the two lines join with where the two arcs join, and that is how you do an angle bisector. All of the arcs leave on the diagram because they are going to get you the marks. Arcs for marks. So when you read this question, the question's basically asking you to find the bearing of O from B. So the lifeboat is at B, so I'm going to draw a north line here. And to find a bearing, you start from the north line and you keep going clockwise. So we're going to look for this angle here. Now, this angle, which is given to us in the question, and this angle here, which I'm just going to call X, are going to be equal. So x is going to equal 135 degrees. And the reason for that is we've basically got, and I'm just going to draw or extend the north line down, because we've basically got well, we have a set of parallel lines here, and we have a set of z angles, which we know is alternate angles. So the reason for that is it's alternate angles. And always show the reasons to the examiner. Okay, and so to find out what the bearing is, so the bearing of O from B, it's just going to be 360 take away 135. And the reason for that is angles on a point. We've run out of space. Okay, so we're going to do 360 take away 135, which is 225. And so our answer is 225. The formula y equals mx plus c includes this m, and the m means the gradient. So if we're looking for something that is parallel to y equals 9x plus 18, we're looking at this number here. And for it to be parallel, it needs to have the same gradient. So we could just write y equals 9x plus or subtract anything. Or we could just write y equals 9x. I'm going to say plus 5. To work out the mass, we will need to find the density and the volume. Density is given to us in the question, but volume isn't. So we need to work out what the volume of this cuboid is. So the volume is just the 33 times the 7 times the 22. So that would be 5,082, and that would be centimeters cubed. And we need to write down the formula for density. So density is the mass divided by the volume. So rearrange this to get mass on its own, because that's the thing we're looking for. So mass equals density times volume. Density is given to us in the question as 2.1 grams per centimeters cubed. Times that by the 5,082 for the volume, and we get the answer of 10,672. And then that will give us grams, because our density is in grams, so that is grams, but the answer is asking for kilograms. So to convert that to kilograms, we just divide by 1,000, and we get 10.672. Then we need to round that to 2 decimal places, and so that would be 10.67 kilograms. So this question says that Adrian, Ben and Charlie have some sweets, and the ratio of Adrian to Ben to Charlie is 9 to 6 to 13. But it also says that Charlie got 56 more sweets than Adrian. So there's 56 more sweets. Well, looking at the actual parts of the ratio, there are 4 more parts. So plus 4 parts, which represent plus 56 sweets. So the 4 extra parts are worth 56 sweets. So 4 parts are worth 56 sweets. So 1 part would be 56 divided by 4, which is 14 sweets. So all we need to do now is work out how many parts there are. Well, there are 9 plus 6 plus 13 parts, which is 28. And each part is worth 14 sweets. So the total number of sweets will be 28 times 14. So 28 times 14 is 392. There is quite an easy way of doing this question, but I'm going to show you the long way, and then we're going to work out what the quicker way is. So I'm going to pair up the A and the 1, which it suggests in the question. Then I'm going to work out the A and the 2 as a different combination, A3, A4, etc. Then I'm going to look at the B and do the same thing, B1, B2, B3, etc. Then I'm going to work out the C, so all the combinations with C. So how many combinations are there with A? Well, there's going to be 7 because there's 7 numbers. How many with B? Well, there's also going to be 7. And how many with C? Well, there's also going to be 7. So in total, there's going to be 7 plus 7 plus 7, which is 21. And the way I can work that out easily is work out how many combinations there are with spinner 1. Well, there's 3. How many combinations there are with spinner 2? 7. And we just times the 2 together. 3 times 7 is 21. So 7 times 10 to the power 4 is going to be 7, and it's going to be 70,000. And 9 times 10 to the power of 7 will be 90 million. And so when you add them together, you get 900700000. Now, if you have access to a calculator, if this is on the calculator paper, then you can just type it into your calculator. Some people think there's a quick way of doing this, like adding the 7 and the 9. There isn't. You've just got to work out what this number is, work out what this number is, and add them together. So we're told that y is directly proportional to x. And so the first thing I'm going to do is replace that proportionality sign with an equals. And to do that, we need to introduce k. So y equals kx. So you just multiply the right-hand side by k. Then I'm going to substitute the values it's given us. So it says to us that when x is 5, y is 4.5. So when y is 4.5, and then we've got x is 5. Then I'm just going to quickly solve that, get my lines in, and divide both sides by 5. And so that's going to be 0.9 equals k. So k is 0.9. So I go back to the equation, and instead of y equals kx, I know that y equals 0.9x. Now k is a constant, which means it will never change, so it's always going to be 0.9. So to find the value of x when y is 5.4, I'm just going to replace y with 5.4, and it's just a matter of solving again. So I get my lines in, and what I'm going to do is just divide both sides by the 0.9 to find out what x is. And when I do that, I find that x is 6. So we're just going to substitute the values that were given into the formula. So v squared equals, and then u is 16.4 squared plus 2 times a, which is 0.2, times s, which is 110.2. Type that into the calculator and you get 313.039 blah blah blah. And what we're going to do is we're just going to quickly solve this by square rooting both sides, because it's v squared equals and we just want v equals. So v equals, and we're just going to square root that on the calculator, 17.692, blah, blah, blah. It says it wants it to 2 decimal places, that's just going to be 17.69. This looks like it's a really tricky question, and it is a little bit tricky, but it's a little bit easier than maybe it looks. The highest common factor is found when you have the prime factors, which we do, of 2 numbers, and you put them into a Venn diagram. Then you can find the prime factor, the highest common factor, by multiplying all the numbers in the overlap. So we're going to rewrite these numbers, just instead of squared, we're just going to write them out without index form. Just makes it a bit easier. And so I'm just removing the squares. And we're going to draw ourselves a Venn diagram. So let's just do a rectangle at the outside. I'm going to try and do some nice circles here. Try my best anyway. Okay, so on the left hand side we have the 450, on the right hand side we have the 132. So we'll start with the 450 and the numbers. So actually looking at the numbers, looking at the factors at the top, the prime factors, we can see they both have a 2 in them, so I cross them both out and put 2 in the middle. We can see they both have a 3 in them, so cross those 3's out and put 3 in the middle. And then 450 has a 3, a 5 and a 5. And 132 has the 2 and the 11. So to find the highest common factor, as I said, you multiply all the numbers that are in the middle. And so the highest common factor will be 6. The first thing to notice is that the tree must be closer to CD than AB. So if we draw a line across the middle, it can't be in the top bit because that would be closer to line AB. The second piece of information that is given to us is it must be at least 11 meters away from point C. So we get our compass out and measure 11 centimeters, or whatever the scale we're using in this diagram is, and we draw a quarter circle from C. And it says shade the region that it can be planted. So this is the region that represents closer to line CD than AB, but also not within 11 meters of point C. We're going to start by focusing on the A and B, which is 8 and 16. So in the middle is going to be 8 and 16. The next thing we're going to focus on is the fact that A is all the multiples of 4. Now 8 and 16 have both already been taken because they're in the middle. So the remaining multiples of 4 are the 4 there and the 12 there. So the next ones I'm going to focus on is the A or B. So A or B is in A, in B, or in the middle. So if we cross out the ones we've already used, so we've already used the 8 and 16 and the 4 and the 12, that leaves the 1 and the 9. We'll cross that out of our other list. And there's only 2 left in our everything list at the top. We've got the 3 and we've got the 11. So on the outside we have 3 and we have 11. So we've got to first of all understand what standard form is. And standard form is a number that is between 1 and 10, but not including 10, times 10 to the power of another number. So to find out what the numbers are going to be for our standard form, we're going to just write down the decimal first. So 0.098. And we've got to put a decimal point in somewhere to make this a number between 1 and 10. So if I put it in here, that would make it 9.8. And we're ignoring the zeros to the left-hand side. So we know that our standard form is going to start off with 9.8 times 10 to the power of something. Now this times 10 is always going to be there. It's never divided by 10 or anything like that. It's always times 10. Next, we've got to find out what the power is going to be. So first of all, if it's a small number, if it's a number less than 1, which this is, it's a small number, it's going to be a negative power. And the next thing we do is work out how many jumps we have to do. So it would be 1, 2 jumps between where the decimal point was and where it is now. So 2 jumps means it's going to be to the power of -2. First thing I'm going to do is add these column vectors. So we're going to add the tops first, and then we're going to add the bottoms. So it's plus minus 14. And so at the top it would be -4, and 11 take away 14 is -3. Then I'm going to pick a point on my shape, and the the top one tells us how far right we're going. So we know we're going 4 to the left because it's obviously a negative. So we're going to go 1, 2, 3, 4. The bottom one tells us how far up we're going. Well, it's going to be down because it's a -3. So 1, 2, 3. And we can do that for each of the other points. So 1, 2, 3, 4, 1, 2, 3, 1, 2, 3, 4, 1, 2, 3. And when we've done that, we can join them all up with straight lines. And label the new shape B. So we're asked to find the bearing of Freetown from Gamley. So that is this angle here. And so what we're going to do is we're going to find this angle, and this will obviously be 90 degrees because the hiker walked west, and it's against the west line and the north line, so it's definitely 90 degrees. So we can work out what the bearing is if we know that angle inside the triangle. So we're going to start by labelling the sides. Well, we've got 90 degrees here, we've got hypotenuse here, we've got the adjacent here next to the angle, and we've got the opposite, which is across from the marked angle. Here we're not using the hypotenuse, so we can cross that out, and we can do our SOHCAHTOA. And the only one that doesn't have the hypotenuse is TOA. And so we're doing tan x equals the opposite, which is 49 over 98. Get our lines in. And we're going to do the inverse tan to both sides. So we get x equals, and we do inverse tan, which is 26.565, blah, blah, blah. Okay, so we know that the whole of the way around up until this point is 270 because we've got this 90 degree left. So what I'm going to do now is we're just going to work out the bearing. So bearing, we're just going to do 270, take away the 26.565, blah, blah, blah. And that gives us 243.434. Blah, blah, blah. It says it wants it to the nearest whole number, so that's going to be 243. I'm going to first of all draw the two triangles out separately. And we've got A, B, C, and then A, D, E. And the first thing to notice is we have similar triangles here, and the way we know that is that we've got an F angle here, which means they're corresponding on the two parallel sides. So these two angles are the same. We've got exactly the same thing on this side. We've got F angles. So these two are corresponding. And then the top angle is shared between the two triangles. And when you've got two triangles with exactly the same angles, they are going to be similar, which means one's an enlargement of the other. I'm just going to put on the length that we've got. Now we're looking for quite a complicated one. We're looking for the length CE, which is this one here. Now I can't actually label that onto my two triangles, but what I do know is that CE is equal to AE minus AC. Now we know what AE is, which is 60. So we just need to find out what AC is, this one here. And when we find out what AC is, we can just take them away to work out what the CE is. So we need two corresponding lengths that we know both of them. So we've got the 9 and 36 here. Because these two triangles are similar, we know that we can work out what the scale factor is. And to work out the scale factor, you do big divided by small. So 36 divided by 9. And we work out that that is going to be 4. So we know we're going to have a scale factor of 4. So to get from the smaller triangle to the big one, we times it by 4. But here we have the one, we need to find out what this one is. So one corresponding is this one. We're going from the big to the small. And so to work out from the big to the small, we've got to divide it by the scale factor. So divide it by 4. So 60 divided by 4 is 15. So we know what this one is. So AC is 15. And so we're going to do AE, which is 60. Take away the 15. And that will tell us what CE is, which is 45. So our answer is 45. So there are three parts that we need to find the area of. We're going to start with the easiest bit first, this circle at the bottom here. Okay, so the circle area is just going to be pi times r squared, and the radius is given to us at the top, which is 9, so it's just going to be pi times 9 squared, and that would be 254.469 blah blah blah. Well, we could leave it as 81 pi. Next bit is the curved bit of the cylinder, so we're going to do the cylinder next. And it's just the curved bit, and the formula for that is 2 pi r h. So 2 times pi times the radius, which is 9, times the height, which is 30, and that will give us 1696.460 blah blah blah. And the last bit is this hemisphere here. And so let's do the hemisphere. And the formula for the area of a hemisphere, well, this full sphere is 4 times pi times r squared, but because it's a hemisphere, it's half of that. And so it'd be half times 4 times pi times the 9 squared. And that will give us 508.938. And so the final thing is to work out the total area, so total surface area. And we're just going to add up all these numbers together. So we add up the 254.469, the 1696.460, blah blah blah, and the 508.938, blah 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 blah. And we get 2459.867 blah blah blah. Do make sure you show the examiner that you're adding these three here. I've not done that because it would waste a bit of time for a video, but make sure you write it down. It says it wants it to 2 decimal places, so that will be 2459.87 centimeters squared. So the first thing I notice is the second equation isn't really in the normal format for doing simultaneous equations. So I'm just going to rearrange it so that we have it where we want it to be. And I'm just going to put my lines in so I can rearrange. So the first thing I want is the x's and y's on the same side. In fact, actually all I need to do is take away 4y from both sides, and we get 5x minus 4y equals minus 7. Okay, so what we do now is we put both our equations down so we can solve these simultaneously. So 5x minus 4y equals minus 7. And you notice the coefficient of the y is already the same, so we don't need to multiply anything. But the signs are different, and the d in different is the d in add. So we're going to add going downwards. So we're going to add everything. So we're doing 3x plus 5x, which is 8x. 4y plus minus 4y is nothing, which is good, because we want to get rid of that. And 47 take away 7 is 40. Alright, let's put our solving lines in. And we're going to divide by 8 both sides. So we get x equals 5. And we're going to substitute that value into one of the equations. I'm going to pick this top one. So instead of 3x, we're doing 3 times 5 plus 4y equals 47. Get my solving lines in. So that will be 15 plus 4y equals 47. And then we're going to take away the 15 both sides. And so it's 4y equals 47 take away 15, which is 32. Divide by 4 both sides, and we get y equals 8. Now we can check that using this equation here. So 5 times 5 is 25. Take away 4 times 8, which is 32, is minus 7. So we know we've got it right. So here we're given a standard form number, and we're asked to make it an ordinary number, which is just a number you type into the calculator. So we're going to start off by writing the decimal, which is 6.2. And we're going to shift that decimal point somewhere that it will be the actual number rather than standard form anymore. First thing to point out is we look at the power. If it's positive, it means that our ordinary number is going to be a big number. If it's negative, it means it's going to be a very small number. Since this is positive, we know it's going to be a big number. So we're going to do 4 jumps, because there's a power of 4, to the right to make it a big number. So 1, 2, 3, 4. So the decimal point is going to be here. And we're going to fill in the jumps with zeros. So 0, 0, 0. So our new number is going to be 62 with 3 zeros, or 62,000. Now it's important to realise that we're actually shifting the numbers, not the decimal point, but it's a lot easier to move the decimal point in our working out. So this question will probably need a Venn diagram just to make it a bit easier. So I'm going to draw a Venn diagram. You don't need to. If you can work out how to do this question without, you can do. But I think this is a really tricky question to do without a Venn diagram. So it says that they picked 2 activities. It was either painting, which I'll put as a P, and sport, which I'll put as an S. So let's start filling in the information it gives us. So 11 picked painting and sport, so that will go in the middle, because that is painting and sport, and 11 didn't pick painting or sport, so they can sit on the outside. Now here's the problem. It says twice as many people picked sport than painting as one of their activities. So it's saying that the total number in, and let's just show it, the total number in the sport circle is twice as big as the total number in the painting circle. Now, what we can do is we can say, okay, so if the painting we label as X, then the sport will be 2X. But if you look, we've already got a number already in the sport, that 11 there. So in algebra, this will be 2X, take away the 11 that we already know about. And the painting is the same. We know the whole thing is X. So what we're going to do is we're just going to take away the bit we know there, which is the 11, and it will be X minus 11. Now we know that there are 66 students in total. So what we can do now is add up all of the parts of the Venn diagram and get it equal to 66. So X minus 11 plus 11 plus 2X minus 11 plus 11, and all of that will equal 66. This is going to be some solving, so we're just going to put our lines in. Now here we've got X plus 2X, which is 3X. And if I put my tool right, there we are. And we've got minus 11 plus 11, minus 11 plus 11. Well, those just cancel out. So we're left with just the 3x equals, and then 66. We're going to divide that 3 both sides. So we've got x equals 22. So if we go back to our Venn diagram now, we can fill in the blanks. So instead of x minus 11 there, we've got 22 take away 11, which is just 11. Instead of 2x minus 11 there, we've got 22 times 2, which is 44, take away 11, which will be 33. So it says, find the amount that picked sport and not painting, which is this 33 here. So we're going to first of all find out how many potatoes were below 22 grams. So we're going to draw a line up at 22 and a line across, and that is 13. So there are 13 potatoes below 22 grams. And so to work out the probability of picking one below 22 grams, it's the amount that we have below that amount, or below that weight, over the total amount of potatoes, which will be 20. So it'd be 13 over 20, which is equal to 65 over 100, so that would be 65%. An exponential growth would show an increase from left to right, but the graph we've got in front of us, or the sketch, is showing it decreasing, so it's going to be a decay. We can write the equation of any linear graph as y equals mx plus c. So m is the gradient and c is the y-intercept. So we've got to find what the gradient and the y-intercept are. Well, I'm going to first of all try and figure out what the gradient is, because we're actually given some clues here. We're told that the line is perpendicular to the equation given. Now I'm going to rewrite this a little bit just to make it a bit clearer what the gradient of this is. So I'm going to write this as minus 1 over 12. I'm just going to leave a bit more of a gap there. Minus 1 over 12 x plus 12. And you can see that the number before the x, the coefficient of the x, is minus 1 over 12. But we're not told that it's parallel to that, so it's not, the equation that we've got is not going to have the gradient as minus 1 over 12. We're told it's perpendicular. Now, when two things are perpendicular, to find the gradient of the other one, if we know one of them, you've got to change the sign and find the reciprocal of the fraction. So to find our gradient, we're going to change the sign, so it's negative, so our gradient is going to be positive, and we're going to flip it. We're going to find the reciprocal. Reciprocal of 1 over 12 will be 12 over 1, or just 12. So the gradient of our line is going to be 12. To find the y-intercept, we're going to use the points given to us. So we've got x equals 3 and y equals 4 for a point on our line. We're going to substitute those into the equation we've got. So it's going to be 40 equals 12 times 3 plus c. Put in our solving lines. 12 times 3 is 36. And we're going to take away that 36 both sides. So it's going to be 4 equals c, or c equals 4. So our equation will be y equals 12x plus 4. We're going to write this out again just to give us a bit more space. So we've got s equals 4 minus 13t over t minus 5. We're going to get our lines in. Okay, so the first thing I need to do is get rid of this fraction. Always get rid of any fractions. I'm going to do that by multiplying both sides by t minus 5. So we're going to end up with s brackets t minus 5 equals 4 minus 13t. I'm going to break open those brackets just by multiplying them out. So it's st minus 5s equals 4 minus 13t. And the objective here is to get all the t's on the same side. So I'm going to add the 5s and I'm going to add the 13t. So add 5s and then add 13t. And so effectively we're just moving this on the other side and this on the other side. So we're left with st plus 13t equals 4 plus 5s. Now when we've got the t's on the same side, we can factorise out the t's. So t bracket s plus 13 equals 4 plus 5s. And then we can get rid of this by dividing both sides by s plus 13. And so we're left with t equals 4 plus 5s over s plus 13. So our answer is 4 plus 5s, all of that over s plus 13. And it can be either way around, so I could have 5s plus 4 over 13 plus s, or anything like that. We're going to start by creating a table of frequencies from this histogram. And so we are going to need our times, first of all, then our frequencies, and then we can add a midpoint and an fx column as well, which we'll need for later. So our times, then our frequencies, then our midpoints, then we'll do the fx later on. Right, so the first group is 0 to 10. And to find the frequency, I might as well just show this. So the frequency density is proportional to the frequency over class width. The class width here is 10, and the frequency density is 1.2, so 10 times 1.2 will be 12. And then the next group is up to 30, so we're doing 20 times 3.2, which will be 64. And then the final one will be 30 to 50. So again, we're doing 20 times 0.8, which will be 16. Okay, so we've got our table from the histogram, and we're asked to find the mean. So hence us doing the midpoint, etc. So the midpoint is 5, 20, and 40. And then the fx, we just times these together, and that would be 60, 1,280, and 640. Now, something I said earlier is that the frequency density is proportional to the frequency divided by class width. It does tell us there are 92 people, and if you do the sum of the frequencies, you do get 92. So we know that it's a one-to-one relationship. Okay, so let's do the sum of the fx by adding up these numbers here, and you get 1,980. So to find the mean, we do the sum of fx over the frequency, sum of the frequencies, and that will give us 21.521, blah blah blah, and 2 decimal places, which is what the question asks for. It's 21.52. So we're going to just quickly write out our sequence, so 9, 22, 41, 66 and 97, and we're going to find the differences of each of them. So that's going to be plus 13, then we've got plus 19, so they're different already. We know that it's not a linear sequence, and that's going to be plus 31. So we now look at the difference of the differences, and so we've got plus 6 again, and plus 6 again. When you have a difference of differences, it's going to be a quadratic sequence, and we're interested in what the difference of differences is, because what we now do is get that 6 and we always halve it, and it gives us 3. Now that 3 is actually really important, because that is the coefficient of the n squared, so we know our sequence will begin 3n squared. So we're going to do a table now to see what the rest of the sequence will be. And we're going to have our term number and our sequence. So term numbers will just be first, second, third, fourth and fifth. So 1, 2, 3, 4, 5. The sequence is just 9, 22, 41, 66 and 97. Now we know that 3n squared is part of our sequence. So what we're doing now is just removing the 3n squared bit and see what we have left over. So we're going to do 3 times 1 squared, which will be 3, 3 times 2 squared, which will be 12, and then 3 times 3 squared, 27, 3 times 4 squared, 48, 3 times 5 squared, 75. And we're just going to remove that from our sequence. So we've got our sequence, and we're removing the 3n squared bit, because we know what that is. We've already answered that part. So 9 take away 3 is 6, 22 take away 12 is 10. So they're not the same with this. 14, 18, 22. Now what do you notice? Well, we notice that these ones here are going up in 4s. So we've got a linear sequence here. So they're going up in 4s. So we know that that will be plus 4n. And then we find the 0th term. So we go back. So 6 take away 4, which will be 2. So it's going to be 4n plus 2. So our total quadratic sequence will be 3n squared plus 4n plus 2. So to find the shaded part of this diagram, we need to first of all work out the volume of the smaller cone, which is at the top, then work out the volume of the larger cone, which is the whole cone shown, and then take them away from each other. So the radius for the smaller cone is 4 and the height is 5. And the radius for the larger cone is 20 and the height is the 20 plus the 5, so it would be 25. So I'm just going to label them A and B. And so why don't we work out the volume for B first? And the formula for the volume of a cone is 1/3 pi r squared h, with h being the perpendicular height. So it's 1/3 times pi times 20 squared times 25, which is going to be 10,471.975, blah blah blah. We're going to work out the volume for A, and this time it will be 1/3 times pi times the radius now is 4, and the height is 5. So that will be 83.775, blah blah blah. So to work out the shaded bit, we're just going to do the volume for B, take away the volume for A. So it's going to be 10,471.975, take away 83.775. And all those I'm going to keep in the calculator to keep the accuracy. And that gives us 10,388.199, blah blah blah. And to 2 decimal places, it's going to be 10,388.20. You can complete a unique version of this paper by going to our onmaths site. Onmaths is full of free content to help you prepare for your exams, such as topic-based papers, demon questions, and mini mocks. If you like what we do, please consider subscribing.